And it would be great if one of you could just confirm that you can see it saying similarity.
Yeah.
Lovely, thank you. So this is the last bit. You'll see from the scheme of work that this is the last bit we're really looking at to do with transformations, which was all the shape business. So we've reflected shapes, we've rotated shapes, we've translated shapes. Remember that meant when you shifted them, we've enlarged them, and we have and then finally the last thing that's left is similarity. Now similarity is or similar shapes are shapes that are bigger or smaller than each other, but they are proportionally the same. So you might just have a rectangle that's twice as big, or a triangle that's half the size. Okay, so similar shapes can be bigger or smaller, but they are effectively the same shape. It's just got a bit bigger or a bit smaller. Now, we are not going to do number 608, Hegarty 608, because it's too easy. So this is not an official one, okay? But you may want to go and do it as an extra, as an extension work towards your first to 50. So there's only one little bit that I really need to help you with on this, and then this is absolutely dead easy, okay? So what we're saying here, triangle P and triangle Q are similar. Okay, here's P at the top, here's Q at the bottom. And what we're basically the key thing is if you've got a similar shapes, the angles remain the same. Okay, the angles remain the same. So because these we're told that these two shapes are similar, this angle here must be 90 because it's 90 in the bigger one. This angle down here must be 57, and then this angle must be the same as that angle there. So what you would need to do first of all is to work out what this angle at A is by remembering that angles in a triangle add up to 180. So you do 180, take away 90, take away 57, and see what you get. I think that's 33 off the top of my head. So if that angle's 33, then that angle down there must also be 33. Now, the only bit that I need to help you with here is the way that Mr. Hegarty explains the angles. And this is a proper way of doing it. We will visit this in the future. So what we are saying down here, that little shape there means angle. We're talking about the angle as you go from X to Y to Z, as you go from X to Y to Z. So we're talking about the angle here. Okay. Now for this second angle here, this is the angle you get as you go from Y to X to Z, as you go from Y to X to Z. So that's this angle here. Now, in short, it's always going to be the angle at the middle letter, okay? Because that's the one you get to as you do the journey, isn't it? So for this first one, as we go from X to Y to Z, it's the angle at Y, so the middle one. And over here, it's as we go from Y to X to Z, Y to X to Z. So that's the angle at X. So when you see it like this, you've just got to think, okay, that's the angle at Y and that's the angle at X. So that's Hegarty 608. So you may want to do that as an extra, but please don't do that to take you over your allotted time for maths. And please don't do that until you've done what I do want you to do, which is number 609. Okay, 609. Now, back to what I said over here. If you've got similar shapes, the angles are the same, and that's what's going on with Hegarty 608. But the second thing is the lengths are proportional. So the lengths aren't going to be the same, but they are proportional. Okay, so I'm just going to model a few of these. These aren't too bad. Okay, now we are told that these rectangles are similar. So one of them, B, is obviously a bigger one, but how many times bigger is it? So what you do, you go and find the number that you know for both shapes. So clearly with this example, we know the left-hand side for both shapes. So you've got to say to yourself, how much bigger is 15 than 5? How many times bigger is that length? Okay, lots of you can just do that in your head and see, I can see that's 3 times bigger. Okay, but how have I worked out that we're going to be multiplying by 3? That's because I've just done 15 divided by 5 equals 3. So this shape is 3 times bigger. So all its lengths are going to be 3 times bigger than for A. So we're being asked to work out X. So we're going in this direction. Now, clearly, if B, all the lengths are 3 times bigger, then the lengths in A are all 3 times smaller. So how are we going to work out this shorter length X? We're just going to do 24, and rather than multiply it by 3, which would make it bigger, we're going to divide it by 3. 24 divided by 3 is 8. So X is 8 meters long. Okay, so so that's all you have to do. Okay, we're saying that all the lengths in B are 3 times bigger, all the lengths in A are 3 times smaller. So that was an example of question 5. Here's an example of question 8. Now again, you can see that the side we have in common is the left-hand side. We're told again the shapes are similar. So we've got to say to ourselves, how many times bigger is shape B? So what you need to do, you go and do 6 divided by 4, and that gives you 1.5. So basically, shape B is 1.5 times bigger. So if you want to work out a bigger side, you multiply by 1.5. But if you want to work out a smaller side, you divide by 1.5. So 15 divided by 1.5, go and get your calculator out and you will go and see that that's 10. So the answer there would be 10 meters. And then finally, for question 12, same idea. So you start off looking for the side that is common to both, and that on this occasion is the top side. So how do we get from 3 to 10? 10.5? I don't know. I'm going to have to do it on my calculator. 10.5 divided by 3. I think it's going to be 3.5, but let's just check. 10.5 divided by 3 is 3.5. So I know that all the lengths in B, if I'm going from A to B, I multiply by 3.5. And if I'm going from B to A, I'm going to have to divide by 3.5. Okay, now the first thing I've got to do is work out X. Now that's the bigger length, isn't it? That's on the bigger shape. So as I'm going left to right, I'm going to have to multiply by 3.5. All right, so I'm multiplying by 3.5. So 7 multiplied by 3.5 is 24.5. So that's the answer for X. Now, for working out Y, you see we're going the other way. Y is on A, it's on the smaller shape. So we're going the other direction. So we're going to have to divide by 3.5. So the same length, the bottom length on B is 31.5. Divide it by 3.5. 31.5 divided by 3.5 equals 9. So length Y is 9. Okay. Now, I've just noticed, it looks to me like on this question, you would just have to put in 24.5 because the centimeters are already there. It's not clear. And I think what will happen, I think I've probably cut it off, guys. I expect it goes and says meters over here already. So all you have to actually go and put in the box is 10. Okay. I don't think you're going to have to put in 10M. I expect the units are already included, and I've just cut that off as I've done the slide. So just thinking about it, going back to my first example, I expect you just have to put 8 in there because meters is already written over on the right hand side. So that's it, folks. So if you wouldn't mind going and doing Hegarty 609 as your homework, and then if you've got time just for that extra bit towards your first to 50, if you could go and do 6.608, that would be great. Okay, cheers guys, bye.